Hello everyone, my name is Fuad Shatara. In this presentation, titled Sampling Microplastic and HABs in the St. Lawrence River, is part of an ongoing collaboration between the Majumdar Lab at the University of Wisconsin-Madison, the Yokota Lab at SUNY Oneonta, and the Twist Lab at Clarkson University. As an introduction to the work that we do, our research is focused on elucidating interactions between microplastics and cyanobacteria and harmful algal blooms within the Great Lakes region. Specifically, we are looking at the potential for microplastics to serve as a surface to transport cyanobacteria and their associated toxins. As I mentioned before, this is a collaborative project done in part with the River Environment and Sensory Observation Network, or REASON project at Clarkson University. The REASON project measures temperature, phycocyanin, turbidity, chlorophyll-a, color-dissolved organic matter, tryptophan, and optical brightener using sensors on the Unit 32 turbine at the Moses-Saunders Power Dam in Messina, New York, imaged here on the right. We have begun constructing a passive sampling device and installing them at the dam. These devices are installed at the end of the REASON project sensors and filter out particulate matter that we intend to use the collected material for in order to identify which species and small molecules are being transported by these microplastics, and also which microplastics are being transported across the river system. We are now in the process of analyzing the samples that we received from this initial trial. Portions of the samples have been filtered for DNA extraction and will be used for 16S RNA sequencing in order to determine which species are being transported through the river by particulate matter, again ideally looking at microplastics. Microplastics will be identified by microscopy and spectroscopy, and you can see the images on the right here are of general particulate matter from these filters, as well as what we believe to be a potential microplastic. On that potential microplastic, you can see what appears to be adhered biofilm, and in an ideal case, we would be able to remove any bound biomass from this and identify that using 16S community sequencing. Additionally, we have preliminary data from the REASON project sensors during this initial trial. They were able to collect chlorophyll-a data at different size fractionations and use that information to identify phytoplankton community composition by percentage. In order to address the issues we met during the initial trialing, we have begun to redesign and modify the system that we're using. While the filters are much the same, we have now changed housing to a 3-gallon stainless steel stockpot and included copper tubing for gas exchange. The filters themselves were cut to be flush with the edges of the stockpot in order to eliminate the possibility of water flowing over the sides, and we're hoping that this system will be able to manage flow for a period of days rather than a period of hours. In the future, we're hoping to be able to install these devices on a regular time interval in order to track changes in community composition and transport over the course of a year. Additionally, this project would hopefully be able to work downriver in areas of more anthropogenic influence, where we know that human waste and human pollutants are entering the water systems, and to be able to filter those out and collect and see the impact of those pollutants on the water systems as well.